Hello friends, this video on light, its reflection and refraction is brought to you by Ansh Mittal, student of Shadin School, Muzaffarnagar. We have to focus on image formation by spherical mirrors. Before moving to the main topic, let us know about various rules for the formation of images by spherical mirrors. Rule number 1. When a ray parallel to the principal focus is incident on the mirror, the reflected ray will pass through the principal focus. In convex mirrors, when the ray which is parallel to principal axis is incident on the mirror, the ray after reflection is diverged or converged to the point which is F, which is our principal focus, and after reflection it will go in the direction of the principal focus. Rule number 2. When a ray passing through principal focus after reflection will pass parallel to the principal axis. In convex mirrors, when a ray is going in the direction of principal focus, then after reflection it will reflect as parallel to the principal axis. Rule number 3. When a ray passing through center of curvature, that is point C, it is direct after reflection it is directed towards the direction of center of curvature. In convex mirrors, the ray which is going or incidenting in the direction of center of curvature after reflection will reflect it back along the same path. Rule number 4. Ray which is obliquely fall on the pole, that is point P, after reflection will obliquely reflected at the same point. Now, what is the meaning of obliquely here? Obliquely is when the angle of incident equals to angle of reflection. That means if it is make an equal an angle at a pole, then after reflection it will make an equal angle with respective to the theta incidence. This means that theta incidence equal to theta reflection, where theta is the angle of incidence as well as angle of reflection. Now, in convex mirrors, when a ray obliquely falls on pole, then after reflection it will also obliquely reflect it back. Now, first of all, we have to know image formation by concave mirror. Now, first of all, we have to know what is the position of the object. Our position of the object is at infinity. It means object is positioned at somewhere at infinity, which is not defined. Now, when a ray is coming from the infinity to the pole, it will also obliquely reflected back in the opposite direction. Same here, when a ray is passing through center of curvature, then after reflection it will reflect it back along the same path. And we know that when the two reflected rays are meet, then their point of intersection is the point of image formation. It means in this figure A dash B dash is the image formation. It means A dash B dash is the position of the image. Now, the nature of the image when the object is at infinity. First of all, the rays are actually meeting at a point A dash, so the image will be real. It is at infinity there is a large object size, but after reflection the image size is very small, so the nature of the image is diminished. It is inverted, as you can see in the below direction it is the image is formed. So and the object position is forward direction, so the image is inverted and the image will form at the focus, that is point F. Now second one, when the position of the object is at focus, here how the image is formed. So when the object is AB, now a ray parallel to the principal axis after reflection will pass through the principal focus. Now second one, when a ray is obliquely fall on the pole, then after reflection it will also obliquely reflected back. Now when as you can see, two reflected rays are not meeting and are produced infinitely, therefore we can say that the image will be formed at infinity, which cannot be defined. So the two rays are actually meet to at infinity, so the image will also be real. Image will be enlarged as the infinity can be have a higher distance than the object. So and third one is the object is at infinity, and last is object is inverted. Sorry, image is inverted. Third one is when the position of the object is at center of curvature, that is C. As you can see, if a ray parallel to the principal axis incidented on the mirror, after reflection it will pass through the principal focus. In the same way, when a ray is passing through the principal focus, after reflection it will goes parallel to the principal axis. Now the two reflected rays are meeting. The two reflected rays, these rays are meeting at a point which is at C. So we can say that the two rays are actually meeting. So the image is real. That image is inverted as the position of the image is opposite to the position of the object. It is at center of curvature. And fourth is the size of the object is equal to the size of image. Fourth one is when the position of the object is between the pole and focus. So we can take the position of the object between here, which is between the focus and pole. So when when a ray is parallel to the principal axis, after reflection it will goes back to and pass through principal focus. When a ray is obliquely making an angle on the pole, after reflection it will also obliquely reflected back. So when we produce it behind the mirror, so we can conclude that they will actually meet at a point. So we can name this point A dash B dash. So here A dash B dash is our image and this line is our object. So as it is produced behind and the formation of image is behind the mirror, so it will virtual, because we are only letting that the ray will actually meet, but at the reality the rays are not meeting actually. It is erect. Second one is it is behind the mirror, as mirror is facing towards that side and the image is formed behind it. It is the since image line is greater than the object line, so we can say that the image is enlarged to that of object. Now at fifth case, when the image will be formed between C and F if the position of the object is beyond C. Our C center of curvature is here and beyond C the object is placed at AB. When a ray passing through the principal parallel passing through the principal axis, after reflection it will pass through the principal focus. And when a ray is passing through the center of curvature, after reflection it will be reflected at the same path. So the two rays are meeting at the point A dash. So we can say that A dash B dash is image and AB is object. Now since the two rays are actually meeting, the image is real. It is inverted, as when the image is real, it will also be inverted. Now as object size is greater than the image size, the image will be diminished, and the position of the image is between the center of curvature and f focus. Last but not the least, we have when the position of the object is between center of curvature and focus. That means we can take it anywhere between the center of curvature and focus. So I took it as AB. And when a ray is parallel to the principal axis, after reflection it will pass through the principal focus. When a ray is passing through the center of curvature, then after reflection it will reflect it back at the same path. So producing it behind the at a downward direction, we find that the rays are actually meeting. So the nature of the image is real. When the image is real, it will also be inverted. And since the A dash B dash, which is image, is greater than the AB, so the image is enlarged and it is beyond C. Now as we have a concave mirror, so it is another mirror, convex mirror. Images are also formed in the convex mirror. So we have to know in convex mirrors there are two cases. First of all, when the position of the object is at infinity, it means object is placed at not a fixed point, it is placed far beyond our reach. So when a ray is parallel to the principal axis, after reflection it will be diverged to the principal focus and reflected back in its direction. Similarly, another ray which is parallel to the principal axis, after reflection diverged to principal focus and reflected back in its direction. So when the two reflected rays are meeting, they are meeting at principal focus. So we can say that the position of the object is behind mirror. It is virtual, as we are considering that the rays will actually meet. It will meet at focus and the image is at behind mirror. When position of the image is between pole and infinity, that means it is between pole and whomsoever it may produce to, or it is infinity. It is infinity. So I took the object at AB. So when I incident a ray on the center of curvature, it is reflected in its direction. When a ray is incidented obliquely on the pole, it will be reflected obliquely. And after producing the two rays, we find that the two rays meet at a point A dash B dash, and the A dash B dash here is our image. So we can conclude that the image will be formed between the pole and infinity behind the mirror, and the image is virtual, as we are considering that the rays will actually meet. Image is erect, as when the image is virtual, it will also be erect. When the position of the object is at infinity, that is the same, but these are two cases. It is at all the in the both cases the position is at infinity, but the proof statement or the ray diagram are different. In this we took two rays parallel to the principal axis, reflected in the direction and converged and converged to the focus. So it is first case. But in second case, when the position of the object is at infinity, the ray, when obliquely falls on pole, it will obliquely reflected back, and when the ray is passing through center of curvature, it will reflect it in its direction. So when we produce the ray behind the mirror, we conclude that these two rays meet at a point a dash b dash, and a dash b dash is our image. So this image is virtual, as we are considering that these two lines will actually meet, but they are not actually meeting. When the image is virtual, so it will also be erect. There it will be at focus, and it will be behind the mirror. Thank you. I think it will prove helpful to you in your studies.